Okay, let's look at exercise 9.8, the centering block. And this one, uh, it looks fairly simple, except for the fact that the top surfaces, planes A and B, are to be at a true 120-degree angle to each other. And that means that angle has to be measured perpendicular to the slopes of those two surfaces. So it makes creating it a little bit interesting, and it's different than things that you've done in the past. And trust me, trying to draw this in AutoCAD is a nightmare. Okay, there's just no way around it because you're dealing with a kind of a dual auxiliary surface. It's sloping in two directions, so drawing it is really difficult in AutoCAD. All right, so we're going to do it in Inventor, and I've got a English inch template part file opened here, and I'm going to create the box. If you don't have primitives menu loaded, come over here, right click, go show panels, and turn on primitives. I like using primitives to do simple shapes with because it's quick, it saves a step or two. So I'm going to go box. I'm going to put it on my XZ plane, and I'm going to rotate that back around and click the center point and come out. My width is 2. The depth is 1.24, and I'll press enter. And the height is 3.24. All right, so there's my basic box. We'll put a chamfer of 0.2 across the bottom. Easy. Now we're going to do a slot here on the front surface, so I'll go sketch there, and I'm going to choose slot center to center, and I'm going to click a point, and the length of the slot midpoint is 0.76. The radius is 0.25. Okay, and now I've got to locate that so it's in the right place. So I'm going to project some geometry. I'm going to use the y-axis, and I can do a coincident constraint of one of those midpoints to the axis, and dimension that top point to the bottom of the edge should be 1.50. Okay, so now that's fully constrained. Now, if when you drew this line for the slot down, if you didn't get a vertical constraint, you'll have to apply a vertical constraint to it, or collinear constraint, one of the two. Okay, and so now I can extrude that. Choose both of the spheres or sides of it. Cut through all. Okay. All right, so now let's do another sketch here for the rectangle slot at the top. So we'll go rectangle, and watch your snap so that it doesn't snap to the edge or the center of that. So I go from the top edge, and this thing is 0.24 wide. But, oh, I hit enter too soon. I should hit tab. Okay, sorry. So we'll apply a dimension to it, and it is 1.24 deep. Okay, so I've got the size of it, and I need to locate it. So I'm going to project geometry of the y-axis again, and go with a dimension from the edge to the center of 0.12. I'm fully constrained, so I can extrude, cut through all. Okay, And so there, that's got my my basic shape. Now, to create the slopes on the top, we've got to do a sketch that is perpendicular to that 60-degree slope on the sides. And so the best way that I have found to do that is we're going to create an angled work plane, and we're going to do our sketch and extrusion from there. So we're going to start with a sketch on the side right here, and I'm going to change over to construction lines, and I'm going to create a line that just anchors on the top, comes down and anchors on the front, and I want to dimension that with the 60 degrees. And then I also want to dimension from the top to the point on the front at 0.5. Okay, so that's got the angle of that sloped surface on the outside edges. Now I want to create a work plane that's perpendicular to that. So I come up here with my planes, and I go down to angle to plane around edge, and I choose the front edge, and then I want to choose the back surface. You can either do the back surface or the XY plane, either one. You just got to move your mouse around till you get that rear surface selected. And then this is going to be 30 degrees because I've already got a 60-degree slope right there. So the angle right here is 60 degrees. I want this angle to be 90 degrees, which makes this angle 30 degrees. And if I look at it from the side view, there's what we got. Okay, now let's do a sketch on the work plane we just created. And I'm going to slice my graphics. You can go F7. And let's see. Now we're going to do a line, and I want to snap it on the outside edge, but watch out that you don't grab that midpoint snap. Okay, so I'm going to anchor there, come down into here, and then come back up to here. Now let's project geometry of that y-axis and do a coincident constraint from that point onto the line. Now we'll dimension those angled lines at 60 and 120. Okay, now I need to constrain it so that this line is on that line. And so I'll go project geometry, and I want to select that construction line that I created. And you notice it put a little yellow dot right there. So I want to do a coincident constraint from the end of this line onto that yellow dot, which is the intersection of the construction line. Okay, now it tells me we're fully constrained. But now in order to do this extrusion, I have to have a closed loop. And right now I don't have that. So the best way to do that is to project the geometry. And a couple of ways. You can just go project geometry and select the top surfaces and these vertical surfaces. That will work. We can go project geometry and go cut edges. That certainly works. It gives us the closed loop. Either way works. The cut edges just saves you a few clicks, okay? All right, and so now we'll go extrude. And I want to choose that trapezoid, I guess. I don't know. If you did the cut planes, you just click twice and select them both. If you projected those surfaces, you'll have to click one for the upper portion and once for the lower portion. All right, and so I'm going to go cut, and it's going to be asymmetrical. And I want to turn sideways to make sure that this is extending both front and backs beyond the edges of the object. Distances are not important. I just want it to cut all the way through the thing. So we'll say OK. And so there we have our part. Okay, so let's hide visibility of that sketch in the work plane. And now let's check ourselves with a measurement between that surface plane and this surface. And we're at 120 degrees. Isn't that cool? That is so cool. I love it. All right, now one last thing I want to look at. Everything else we've done in this class has been like to 4 decimal places. So before you finish with this part, I want you to change your document settings for this to 4 decimal places on both linear and dimension, because we're going to be using our model to check some sizes in a quiz, just like you've done with the AutoCAD drawings, okay? All right, and so that's that right there. So you want to save that. Last name, 9.8, you know, whatever it says in Blackboard, save that, because you're going to submit both the model and a drawing and do the quizzes.